have also provided in Edmodo. And as you can see, it was lifted from the MathWorks site, the people that make MATLAB. And so, of course, it doesn't come out this clean on their website, but I've segregated it because we can have a teaching moment. So projectile motion, many of you have had physics, so this should be fairly easy to absorb. And the rest of you, you still be able to get it. But we'll walk through it here. And so, some of the cool things MATLAB does here. All right, so in part one here, we need to set up a few variables and ask the question, why start with z velocity and acceleration? And so I set it up. I'm going to call it VZ, velocity z, so to speak, shorthand. And I'll just give it 10. The units don't matter because we're not, they're all basically forced into the same unit since we're not declaring any of those here. And then A for acceleration, minus 32. So minus 32 would be associated with feet because the acceleration due to gravity in feet per second squared is 32.2 technically. And so, but 32 is close enough. So we set that up, and why we did this first will make sense in a minute. Now in part two, we need an equation for the part of motion that's subject to acceleration, which is going to be up, which is our z dimension. And this equation right here, if you've had physics, that should look familiar. You have an initial velocity times time plus 1/2 acceleration times time squared. Notice here that the time squared calculation, since time is technically a vector, if I want to square every element in this vector, which there would be a few, 10 of them, so to speak, from 0 to 1 in 0.1 increments, I've got to do the element-wise vector exponentiation here to 2. So I declare what VZT is and what that is there. And this is basic stuff in physics semester 1. So we have the equation of motion that's set up for the part of motion that's subject to gravitational acceleration, which is contingent on time and, of course, the acceleration value. The things that go into an equation like this must be declared prior to the compiler doing anything with them. If these were to appear later, we'd get an error. So that's why these things went first. Now in part 3, we need to set up the rest of the stuff that's going on. If it's in 3 space, it's going to have an x velocity, which is a horizontal velocity, and we could give it another horizontal velocity, y. You're used to y being up. Well, now the xy plane is the horizontal plane where we walk and talk and move around, and z is the up direction. So that's the shift in thinking. And x velocity, we give it some value, and that means that the x position at any given point in time would be the product of its rate and time. Distance, x equals rate, vx times time. And then the same would be true for the y dimension, which is also another horizontal dimension. In the horizontal dimension, there is no acceleration. Of course, we're ignoring air friction, which technically would present some acceleration, but we're leaving that out so that this can be simple, relatively speaking. So now we're down to part 4, and this is where the physics ends, and this is where the computer starts doing stuff for us mathematically. And these functions here, when you get into, I believe, Calculus 3 and some other higher math and physics, the gradient is a function, and it's a slope function basically. And so I create a new variable called u that's the slope of this x thing at any given point in time. Same for v and w. So I have my x, y, and z gradients that I've given them another variable. Why do I do that? Well, the fancy schmancy function that does it requires these gradient inputs for the slope as well as what the positions are in time at any given time. And then this scale thing, I'm going to let you play around and see what happens there. And then this view thing, this is just a thing that lets you kind of tilt the axis around, as I've said here in the comment code. So one of the things I'm going to have you do in your journal reflections is play with this and think about how you might modify it, change it, why things make sense, why they don't make sense, etc., etc. So with all of that, let's see what happens. So I come up here, and by the way, I'm in the editor, which you can get from the file menu, uh, and start writing a program as opposed to just using the command line. That's all you've seen so far. And so let's run this projectile motion thing that I've already saved, and here we go. Let me bring this down into view here, and so we get, let me stretch this out a little bit so we can have a better view of it. And there's a lot of nifty things here, like there's this tilt thing that lets me kind of tilt it around, so you kind of might see from a different angle how this projectile motion might be tilted up. See, it kind of goes up a little bit in space, and it's coming at you. There's another nifty thing, a value plotter. There we go. And it's kind of hard to see, but it gives you x and y positions, x, y, z positions at these particular points in time, and it gives you the slopes, the gradients, if you will, values, which is a little calculus thing that we won't worry about too much in this course. And there's some other nifty features. We can, where's my plot editor? There we go. Edit plot. So bring this down in here. We can put a title on the x-axis. Call it x direction. And let's see here. Let's give the font, make it a little bit bigger so we can see what's going on there. And that got put up there. Y-axis. So we could change these plots. Let's see. Oh, I'm sorry. That's the title. Pay attention, Van Gilder. Projectile motion. Let's do something fancy here. How about, oh. So you can see you can change various features like that. And that's kind of a nifty little tool. I'm going to close out that figure. So here I give you this stuff, and these pieces of code, you can run all of these from the command line, by the way. Just enter them, all the stuff that's in black here, and it'll give you the same output. But here in this little program, it's kind of a nice feature. It's easier to follow. You're able to comment it a little bit nicer, and it's its own freestanding program. And we could enhance it, and we will as the course goes on, so where you ask the user for inputs, what is the velocity in the x, y, z direction? And then those would come into it, so you could perhaps write a function where you input 3 values for velocity, and when you run it, it calculates the new vector for you. So that's just a quick peek at how you can use this. In fact, then we're in the cell mode, which is also in one of the Getting Started videos, which helps you publish these things nicer and run them, talk about them, etc., etc. So I'm going to stop right there and be looking for some new stuff coming soon.